bomber built in the 1950s just flew nearly 9,000 miles to drop 70,000 pounds of weapons on Iran. No stealth, no hiding. Just a massive, loud, old plane going straight at one of the most missile-heavy countries in the Middle East. And it worked. So how does a Cold War relic survive in a modern war? That's exactly what we're getting into today. We're going to walk through a real B-52 sortie during Operation Epic Fury, start to finish, and by the end, you'll never call this plane old again. By the time the B-52 drops its first weapon over Iran, the crew has already been flying for hours. Not from a base in Qatar or Diego Garcia, from Louisiana. Barksdale Air Force Base, sitting right in the middle of the American South, is where these missions kick off. Sometimes it's Minot, up in North Dakota. Either way, you're talking about a bomber launching from deep inside the continental United States to hit a target on the other side of the planet. That's not an accident. Here's why the Air Force does it this way. A bomber sitting at a forward base in the Middle East is a target. It can be hit on the ground before it ever takes off. But a bomber sitting at Barksdale? Nobody's reaching that. So flying from home soil is partly about protection, and it's partly a message. The US is basically saying we don't need to park planes next door to threaten you because we can hit you from anywhere. The specific variant flying these missions is the B-52H, and it has a range of nearly 9,000 miles without refueling. So on paper, it could make the round trip to Iran and back without stopping. In practice, that's not really how it works, but the range tells you something important. This plane was built to reach anywhere on Earth, and that's still exactly what it's doing. Inside the aircraft, you've got 5 crew members: pilot, co-pilot, radar navigator, and an electronic warfare officer. That last one is specifically there to deal with enemy radar and missile systems. So the crew is already thinking about threats before they're anywhere near Iran. And all 5 of them are sitting in a plane that was designed in the early 1950s. The basic airframe is older than most of their parents. But here they are, flying a combat mission that the people who drew the original blueprints couldn't have imagined. The route takes them east out of the US, across the Atlantic, down through the Mediterranean corridor, and then into the broader Middle East theater. That outbound leg alone can run somewhere between 15 and 20 hours, depending on exactly how they're routing the mission. So by the time the crew is anywhere near Iranian airspace, they've already been in the air longer than a full workday. They haven't dropped anything yet. They haven't done the actual job yet, they've just been flying. Barksdale and Minot are roughly 9,000 miles from the target area, and that distance is the whole point. The B-52's range isn't just a number on a spec sheet. It's the reason this mission is even possible in the first place. But that distance creates a serious problem the mission planners have to solve before the bomber ever gets close. So let's take a look at what happens next. A 185,000-pound aircraft flying at 500 miles per hour trying to hold perfectly still. That's what mid-air refueling actually looks like, and it happens multiple times on a mission like this. The B-52 burns through fuel fast. Even with those massive internal tanks, a round trip to Iran chews through more fuel than the plane can carry. So at minimum, the crew is looking at 2 or 3 aerial refueling contacts each way. Sometimes more, depending on exactly how the mission is routed. That's not a minor detail. That's a whole separate logistics operation running in parallel with the strike itself. The tanker aircraft are usually KC-135s or KC-46s, and they have to be pre-positioned along the route before the B-52 even takes off. So a single B-52 sortie is actually pulling in multiple tanker aircraft, multiple tanker crews, and precise timing spread across thousands of miles of airspace. You're not just launching one plane. You're launching a chain of support that stretches all the way across the Atlantic and into the Middle East theater. Here's why the timing piece really matters. If a tanker is even slightly off schedule, or weather pushes the B-52 onto a different route, the whole timeline shifts. And this isn't the B-52 flying alone. It's part of a coordinated strike package with B-2s and B-1Bs hitting targets at the same time. Everyone has to be where they're supposed to be, when they're supposed to be there. A late tanker doesn't just inconvenience one crew, it can ripple through the entire operation. The refueling itself runs about 20 to 30 minutes per contact. The boom operator on the tanker physically flies a metal boom down into a receptacle on top of the B-52, and then fuel starts transferring at hundreds of gallons per minute. Both planes hold formation the entire time. For the B-52 crew, this is something they've trained on hundreds of times, but that doesn't make it easy. You're flying a massive jet in tight formation with another massive jet, often at night, sometimes in turbulence, over open ocean where there's nowhere to land if something goes wrong. The B-52J variant coming in the future is getting new Rolls-Royce F-130 engines, and those are supposed to cut fuel burn by around 30%. Fewer refueling contacts, fewer tankers, simpler logistics. That's a real operational improvement. But the B-52H flying Epic Fury right now is still running the old TF-33 engines, so the tanker coordination is a hard constraint on every single sortie. At minimum, 2 to 3 refueling contacts each way. That's what it takes to get this plane to Iran and back, and the whole system has to work perfectly every time. The plane is fueled, the crew is hours deep into the flight. Iranian airspace is getting close, but they're not going in first. The B-52 has no stealth coating, no special shaping, nothing that helps it hide from radar. It shows up on a radar screen like a flying warehouse. So the question was never how does it sneak in? It was how do you remove the threat before it gets there? Iran had built up a serious air defense network. We're talking Russian-supplied surface-to-air missile systems, domestically produced missiles, radar sites spread across the country, all of it overlapping so there aren't easy gaps to slip through. That's not a simple problem. You can't just fly a non-stealth aircraft into that environment and expect it to come out the other side. So before the B-52s ever got close to Iranian airspace during Operation Epic Fury, Israeli strikes had already been hitting that network. Radar sites, surface-to-air missile batteries, command nodes, the infrastructure that makes an air defense system actually function. The goal wasn't to wipe out every single missile in Iran. The goal was to degrade the system enough to create workable gaps, and that's exactly what happened. Here's why that distinction matters. You don't need a complete blackout of enemy air defenses to operate. You need enough degradation that the threat level drops to something manageable. Israeli strikes created those conditions. They knocked enough pieces out of the network that the incoming strike package was operating in a much more permissive environment than it would have faced against a fully intact system. And this is actually a classic sequencing strategy that the US military has used for decades. Stealth aircraft go in first because they can survive in a high-threat environment where everything else would get shot down. The B-2 is nearly invisible to radar, so it can fly into defended airspace, hit the air defense nodes directly, and start clearing the path. Once those threats are down, the airspace opens up for non-stealth platforms like the B-52 to come in behind and do the heavy lifting. That's the division of labor. The B-2 is the tip of the spear. It hits the hardest targets first and clears the way. Then the B-52 follows, carrying 70,000 pounds of munitions, and hits everything that's left at a scale the B-2 simply can't match on its own. CENTCOM described Epic Fury as nearly double the scale of the 2003 Iraq strikes. So you're talking about a massive coordinated operation where the B-52 is the primary heavy bombardment tool, not the aircraft taking the biggest risks. So the B-52 surviving in modern combat isn't really about the B-52 at all. It's about the system built around it. The Israeli strikes degrading Iranian radar and missile batteries enough to create the gaps the strike package needed, and the B-2 finishing that job from the inside. Now the airspace is open. The B-52 is closing in on the target area, and it's carrying enough firepower to level a missile production complex. So let's talk about what actually happens when it gets there. 70,000 pounds of weapons. People hear that number and it kind of washes over them, so think about it this way. That's 5 full-size pickup trucks, all of it explosive, all of it going into a single target area. That's what the B-52 is carrying when it finally reaches Iranian airspace. The specific targets during Epic Fury were ballistic missile facilities, command and control posts, hardened bunkers, the kind of infrastructure Iran spent years and serious money building underground specifically so it would survive an attack. So you need weapons that can actually get through concrete and dirt before they detonate, and you need enough of them to hit multiple aim points in the same mission. The weapons load is tailored to whatever the target set looks like. GBU-31 JDAMs are GPS-guided bombs. They're accurate, they're reliable, and the B-52 can carry a lot of them. For hardened underground targets, you're looking at something like the GBU-28, which is a bunker buster specifically designed to punch through reinforced concrete before it goes off. And then there are cruise missiles like the AGM-86, which the crew can launch from well outside the target area and still hit precise coordinates. So the B-52 doesn't even have to fly directly over what it's hitting. It can stay at a safe standoff distance and still put a weapon exactly where it needs to go. That standoff capability also matters for mobile targets. Iran uses mobile ballistic missile launchers specifically because they're hard to find and hard to kill. You move them around so nobody knows exactly where they are. The B-52 can loiter over a search area for an extended period, and the moment a launcher gets identified, weapons are away in a matter of seconds. That endurance, the ability to just stay up there and wait, is something a smaller strike aircraft with less fuel and a lighter payload can't really replicate. And the volume is the whole point. A single B-52 can hit multiple aim points in one pass, or it can saturate a larger target complex all at once. One aircraft doing the work that would otherwise take many smaller planes. That's the force multiplication argument, and it's pretty straightforward when you lay it out like that. After weapons release, the crew turns the aircraft back toward the tanker track, takes on more fuel, and starts the long trip home. By the time they land at Barksdale, they've been airborne for 20 hours or more. The whole flight, thousands of miles each way, hours of open ocean, multiple refueling contacts, all of it to spend a relatively short window over the target area. That's the mission. And that's the thing about this plane most people miss entirely.